All right. So, number 6. They are dropped. So the VIs are 0. The A's are 9.81 meters per second squared. But it says the second one is dropped after the first one. So delta T1 and delta T2 will be delta T1 minus 1.6 seconds. So delta D1 will be VI delta T plus 1/2 A delta T squared. This goes to 0. This is number 1. Delta D2 will be VI delta T 1/2 A delta T2 squared. This one goes to 0. It wants to know how far is the second one fallen when they are 36 meters apart. So D1 minus D2 has to equal 36. So fill these in, and we'll have 1/2 A delta T1 squared minus 1/2 A delta T2 squared is equal to 36 meters. Okay, but now we have 2 unknowns. We have to fill this in for our time for number 2. So 1/2 A delta T1 squared minus 1/2 A delta T1 minus 1.6 seconds squared is equal to 36 meters. So you can multiply by 2 if you want to get rid of the 1/2, and it would be A1 squared minus A, and now you have to FOIL this. So T1 squared minus, and there'll be 2 of those center terms, and then plus 2.56 seconds squared, and over here this will be 72 meters. Multiply through by the A, so T1 squared minus A T1 squared minus 3.2 seconds times A times T1 minus A times 2.56 seconds is equal to 72 meters. These two are going to cancel, and so we'll have 3.2 seconds times A. T1 will be equal to 72 meters plus A times 2.56 seconds squared. Okay, get the T1 by itself. 72 meters plus A 2.56 seconds squared over 3.2 seconds times A1. Fill in your numbers. A1 is just 9.81 meters per second squared, of course. Squared. And then on the bottom, 3.2 seconds times 9.81 meters per second squared. When you do this, you'll end up with meters on the top, meters per second on the bottom, which will then give you seconds, and you get 3.093578 seconds. Okay, that's the time for the first one, but the question wants to know how far did the second one fall. So you need to use this to find out the time for the second. It's just going to be that 3.093578 seconds minus the 1.6 seconds to get your T2. And then once you have this, fill it in there to get D2. And you should get D2 to be 10.94195 meters. Okay, so that's number 6. I also asked for number 7. You also asked for number 7, which is a ball thrown vertically upward. So ball 1, thrown vertically upward, VI, with a speed of 11 meters per second. Up. A will be 9.81 meters per second squared. Down. Ball 2, thrown upward, VI is equal to 25 meters per second. Up. A is 9.81 meters per second squared. Down. And the question says, find the time it takes for this, one's a ball, one's a stone, sorry, for the stone to catch up to the ball. So this one is the stone. Okay, so when it catches up, D1 should be equal to D2. The problem is the second one is thrown 1 second later. So delta t of the stone is equal to delta t of the ball minus 1 second. So again, delta d of the ball will be vi delta t, 1/2 a delta t squared. This is ball and ball. And delta d of the stone, vi delta t, plus 1/2 a delta t ball squared. And so they should be equal. So vi delta t of the ball plus 1/2 a delta t of the ball squared is equal to vi delta t of the ball. Oops, stone. Be good if I had different subscripts in it. Plus 1/2 a delta t of the stone squared. Again, we have two unknowns, so we need to sub this in. And it is going to be a little painful because this time we have to sub it in two different spots. So vi delta t, vi of the ball, delta t of the ball plus 1/2 a delta t of the ball squared will equal vi of the stone delta, and instead of the stone's time, we're going to put in delta t of the ball minus 1 second plus 1/2 a brackets delta t of the ball minus 1 second squared. So all this side stays the same. This side becomes vi of the stone delta t of the ball minus vi of the stone times 1 second plus 1/2 a, and then we have to FOIL this, so delta t of the ball squared minus 2 times 1 second delta t of the ball minus plus 1 second squared. Okay, so vi of the ball delta t of the ball plus 1/2 a delta t of the ball squared equals vi of the stone delta t of the ball minus vi times 1 second plus, and now we have to multiply through, 1/2 a delta t of the ball squared. 1/2 times 2 should be 1, so 1 second times a delta t of the ball. And then multiply again, so 1/2 a times 1 second squared. Now, we got a 1/2 a times delta t of the ball squared, and we got a 1/2 a times delta t of the ball squared. Those disappear. Here's a term with a delta t of the ball. Here's a term with delta t of the ball. Here's a term with delta t of the ball. There's no t squared term left, so it's not going to be a quadratic. So vi of the ball delta t of the ball minus vi of the stone delta t of the ball, and plus 1 second a delta t of the ball. On this side, that's this guy, and this guy, and then we're left with vi of the stone times 1 second, and it's a negative, plus 1/2 a 1 second squared. Okay, you can pull your delta t out here. So vi of the ball minus vi of the stone plus 1 second times a equals vi times negative vi 1 second plus 1/2 a times 1 second squared, and then divide by the bracket. So negative vi times 1 second, going to run out of time here, but I'm trying. 1/2 a 1 second squared divided by vi of the ball minus vi of the stone plus 1 second times a. Fill in your numbers. So a negative, that's stone. So which one's that? It's the stone. So 25. Negative 25 meters per second times a second is going to be 1 plus 1/2. You're throwing it upward, so negative 9.81 meters per second squared by 1 second squared. On the bottom, 11 meters per second minus 25 meters per second plus 1 second times negative 9.81 meters per second squared. Okay, and I'm going to run out of time, but I'm hoping when you do all